Okay, this looks like this is on. Okay, so hold on one second. Get this here back there. Okay. So today is once again June 30th, and the time, hold on, is 11 o'clock, 11 p.m. So I got to go to bed pretty soon because I got to wake up for work tomorrow. But before I do, I'd like to dedicate this post to a good friend of mine, Alfonso Esquada. He came up with an interesting theory as to what I call an insight into the way the quantum world works. It's a very interesting theory, something I never really thought about before. Before I explain it, first of all, you got to understand a little bit about what quantum physics is, okay? So, I'm going to give a symbolic understanding so you don't have to try to go to the libraries to get books and look up all the other various things about physics. Okay, physics has to deal with the laws of how physical motion works, the laws of how other things work, the properties of nature, electricity, all the different forces, the scientific forces. Okay, for instance, for every action there's an equal and opposite reaction. You get things like that. Gravitational forces, the way gravity works. Gravity is a very interesting concept. Sir Isaac Newton made a discovery, for instance. You could be on top of a building and, let's say, drop a 10-pound weight. Okay, let's say you get a 10-pound weight from the gym and you drop, let's say, a sack of feathers. Well, you would think, for instance, a 10-pound sack of feathers, right? You would think that perhaps the weight would go down quicker, but no, they both still go down at the same time. Okay, laws of motion. So we're talking about just physics, okay? The way planetary motion works, things like that. So basically, physics deals, for the most part, with what's called the macrocosmic world, the larger world. Now, when you get into things like quantum physics, now you're getting into what's called the subatomic world. The subatomic world gets a little bit more dicey because things that ordinarily would apply to the macrocosmic world may not necessarily apply to the quantum world. Here's an example. For instance, let's say if you were to observe an electron under a subatomic microscope, okay? When you make an observation of an electron, while you could determine its location, you cannot determine its pathway, where it's come from. It's impossible. You cannot determine both the pathway as well as the location of electronic particle. Okay, now if you don't observe the electronic particle, the particle is said to be what's called a statistical frame of reference in many places at once. You cannot determine its location. In other words, what they say is that in many places at once through the quantum wavelength that applies to it. Okay? Another thing that's weird about quantum physics, so if you make an observation, let's say, of the same electronic particle under a subatomic microscope, you not only determine its location through its observation, but you also determine what has happened to it in the past, which is kind of bizarre because what you're basically saying is that your observation of a subatomic particle has actually altered the past from which it's come, because your observation fixes it in some strange way, whereas if you don't observe it, it's a wave. It functions as a wave. Okay, they've done experiments to prove this through what's called single slit experiment as well as to double slit experiments. You send an electronic particle, let's say you shoot it through an electronic gun. A single slit will appear behind the screen as dots, double slit as a wave. So these things are real. It's really a very fascinating subject. But once again, before you could get to that, you got to first study the physics, and then you jump to the quantum physics. Okay, so here's a very interesting concept that my friend Alfonso Esquada came up with, okay? So, follow this, okay, because once again, this is all symbolic, okay? Now, we're going to talk about the scientific dimensional fields, okay? Everybody knows this, okay? One dimension, okay? One dimension, see that is a single line. Okay. Two dimensions, okay. So one dimension you got the horizontal, two you got the vertical, okay. Length and breadth, okay, there you go. Okay, three dimensions, you know, length, breadth, height. Okay, so let me do this like that. Everybody knows this. Everybody went to school. Okay, this is just basic. Think about geometry. When you went to school, you learned geometry. Okay. Three dimensions. Okay, there you go. Okay, now the fourth dimension. This is where it starts getting very interesting. Now check this out, okay? Now, follow this. Okay, now you see this, right? I'm not done yet. Now, imagining intersecting a line from the fourth dimension, from the past into the future. So I'm going to put P, past, future. Okay. So you see that? There's the P, and there's the F. Past to future. Now, this is where it gets very, very interesting. We're going to do the same thing now, except in the opposite directions. First one's coming from the past, so you look behind and then it extends out into the future. Now, the other one is going to be from the future, but this time going back into the past. So this time the line is forward. Okay. There you go. So now you're getting to what's called a 4D frame of reference, okay? Now, this stuff gets very fascinating. Now, follow this along, and Alfonso, you know, I'm giving it to you, the insight that came to me, what you told me about. I'm going to bring that up very shortly. Now, let's get into particle forces, okay? Give you an example of an atom. And then, of course, the electron swirls around the atom. Okay? So you get stuff like this. Okay? Stuff you used to see when you used to go to school. Okay? This is a very basic drawing. Excuse my drawing, but you got the protons. Okay? Then you got the electrons. Okay? You got the neutrons. Okay? So, basically, with all this, okay, you got to remember, for instance, things like an electron. An electron, if you were to, let's say, do an experiment with it in which you could switch the angular momentum of it, you could switch it from an electron to a positron, okay? Electron forward in time, positron, say, does the same pathway but backward in time. Okay, once again, quantum physics, your observation of particles determines its reality, whether it's going to be a particle or a wave, your observation of it, okay? Now, this is where it gets really fascinating. Follow this along and let me know if, you know, if what you think about this, okay? So, our observation of reality determines that reality. Now, this is where it gets very, very heavy. Now, what if a person's belief system is completely different than another person's to such a degree in which they don't die until they know they're going to die? But they don't know they're going to die. They don't die until they know they're going to die, but they don't die until they know they're going to die, but only from their perspective. Only from what they experience as their universe, which they take to be a single universe, but according to the laws of quantum physics, there are definitely what's called a multiplicity of parallel universes there, because you would have to have parallel universes to account for the observer effect. If I don't observe the electron particle in a microscope, it's in a statistical frame of reference many places at once. That's parallel. Once you look at it, if the wavelength collapses, that's the Copenhagen interpretation, into a single universal observation to a single universe. But that's only one interpretation of Copenhagen. People who study quantum physics will tell you about the Copenhagen interpretation. Okay? But there's another guy, I think in 1957, his last name was Everett, put out a PhD thesis on parallel universe. He says that the quantum wavelength doesn't really collapse, except that it splits into another universe, okay? And that interpretation is just as valid. In other words, an observation of something you don't collapse into that particular universe. What happens is that both realities somehow slips into both universes. So check this out, okay? And this is especially for Alfonso. I hope you're following this, Alfonso, all the way through, okay? Because I'm doing what you asked me to do, to put into like a physics equation, or physics understanding of physics. Suppose you have a person who's in a high risk level job, let's say as a police officer. And let's say that police officer over a period of 7 years has dealt with many, many situations that could have got him killed. Now, during those intense situations, each and every single time, he managed to escape, to pull it through, to quell the situation, to get it under control, to do what he had to do as a police officer. So from his point of view, he never died. But that's only his point of view. But because his belief system was so strong that he wasn't going to die until it was time for him to die, he in fact didn't die, but only from his point of reference, his own observation, from a multiplicity of parallel universes out there. Each situation that he encountered that potentially could have put his life in danger in a particular parallel universe, he did get killed. It didn't go the way it should have went, because when things happen randomly, meaning random causes and effects, has nothing to do with spirituality or anything else like that. It has to do with the scientific field of random events. They just randomly happen. So let's say that police officer were to all of a sudden get killed in a particular incident. In that universe, it's a funeral for him. In that universe, his wife and his kids are there, and they're crying. In that universe, he's dead and gone. But because his belief system was that it was not yet for him to die, without him knowing it, he doesn't experience death at all. He just jumps to another parallel universe where his wife is alive, his kids are alive, and from their perspective in that parallel universe, in fact, he didn't die. Because his belief system was so powerful, so strong, he literally observed himself into a parallel universe in which he overcame that particular situation. But that was only in that universe. According to the Everett interpretation of the way quantum physics works, it just so happened that he slipped. In other words, one part of him went where he died, the other part went where he lived. But his belief system was so powerful, his consciousness was only into the field in which where he lived. Okay, that other universe he did die, but his consciousness is just not located there. Okay. So then it would happen there. It could happen another time. Another thing he would have to do. He might have experienced death maybe 10, 20 times as a police officer, going into high-risk neighborhoods and dealing with high-risk, dangerous situations. And each time there was a funeral for him. His police buddies were there, the police academy, wherever, he was located at. They came with their uniforms, with a coffin. But each time, because his belief system, it wasn't yet ready for him to die, he just so happened to transfer yet again into another universe in which he doesn't experience death until he knows it's time for him to experience death in that particular universe. It's a very interesting concept because, today's physics is taken very, very, very seriously, the concept of parallel universes. Even in my own lifetime, I felt there was definitely several times in which I came very close to death, but somehow cheated it. But see, that's my perspective. What if those other particular incidents that did happen in which I did die? But because in my consciousness it was not yet ready for me to die, I'm still jumping from universe to universe to universe, in which I live in those universes, okay? So it's an interesting concept, a very interesting concept, okay? It's like, for instance, let's say you're married to somebody who you really love, okay? I'm sure everybody's life, most people love more than one person, for instance, okay? Let's say you're married. Let's say you're married to somebody who you feel is really your soulmate, but then you look back, or there might have been two other soulmates. You could have got married to those people, okay, without even knowing it. Okay, but it's just that your consciousness happens to be so strong that for you, you had to marry the person who you married, okay? Something like that, anyhow. I don't know if I'm making sense. I think I'm kind of going off on a tangent right now, okay? I'm kind of going off on a tangent. But bringing it back to, let's say, the example of a police officer, okay? He goes through dangerous situations, okay? And that police officer cheating death, okay? That's a good example. Another example would be like a war vet, person who fights in wars, okay? Many times, especially with high intense battle, how you hear soldiers say, hey, I don't know why my buddy got shot, but I didn't. Well, how does he know he didn't get shot in some other parallel universe, eh? It's very, very dicey here. But it's a theory that has to do with the observer effect. Okay, so there is a correlation, and I think there's a very strong possibility of perhaps there could be something to this. So, okay, Alfonso, I hope this helps to explain it more from a physics equation type of thing. Okay, I think I've talked almost 17 or 18 minutes. Okay, so I think I'm going to hold it there. Okay, good night.